Good day, students. Welcome to mathgotserved.com. Hopefully you're having a wonderful day wherever you're at. In this presentation, we're going to be going over how to evaluate indefinite integrals using the use substitution method. This standard is covered in AP Calculus AB or Calculus 1. There are 6 practice problems at the end of this presentation, so don't forget to try those out. It gives you an opportunity to demonstrate mastery of the problems covered in this presentation. To gain access to the entire playlist, the course material, worksheets, just take a look at the link in the description below to gain access to that. If this sounds like what you're looking for, do not forget to hit the like button and also the subscribe button in order to gain updates to future uploads. Alright, let's take a look at the instructions for the examples that we're going to be doing. We're to evaluate the following integrals. So for question number 1, let's say we are to evaluate the integral of 5 cosine 5x dx. Now just a real quick recap, let's go over what the use substitution formula is before we get started with the example. Alright, so the use substitution formula is given by the integral of f of g of x times g prime of x dx is equal to the integral of f of u du, where u is equal to g of x. So the beauty of the use substitution formula is that it enables you to write down complicated integrals in a form that's easy to evaluate when you carry out the substitution. Think about the use substitution formula as a reversal of the chain rule differentiation rule. Okay, so you're basically recomposing a function that has been broken down using the chainful differentiation procedure. Alright, so we're going to be applying that here. Now, let's rewrite the problem. We have the integral of 5 cosine 5x dx. So I'm going to rewrite it in the form where it's easy to identify what u and its derivative is. So I'm going to write this as the product of two functions, the composite, cosine 5x, and then I'm going to put 5 dx right here. Alright, so this is a composite function, so an appropriate u will be the inner function. Okay, so let's call that u. Now if that's u, then we need to find out what the other component is going to be. So u is 5x, so let's differentiate that. So du dx, so you have du dx is equal to 5, so you can just multiply. So let's do that. Du dx is equal to 5. And then we multiply both sides by dx. You have du equals 5 dx. In most textbooks, you can just jump from this first step to the third one. Alright, so du is equal to 5 dx. That's fine. Alright, so what we have is a perfect match right here. Notice what du is. Du is 5 dx, so we know exactly what this other component is. So 5 dx represents du. It is extremely important to know what u and du is before you carry out your substitution. Okay? Alright, so now we are ready to carry out our use substitution. This integral now becomes the integral of cosine u du. So this is a less complicated integral compared to the original problem. Now let's go ahead and integrate this using the rule for integrating trigonometric functions. The antiderivative of cosine u is sine u. So we have sine u. Since it's an indefinite integral, we have plus c. Okay? Now, this is a substitution step. When you're done integrating, so this is a sub step. When you're done integrating, don't forget to resub. Okay, resub converts it back to the original independent variable that you were given, which is x in this particular case. So when we are resubbing, we're going to take out u and replace it with what we substituted it out with, which is 5x. Alright, so our final answer is going to be sine of, instead of u, 5x plus c. All right, so that is the answer to question number 1. All right, let's take a look at another example. Question 2. What if we were to evaluate the integral, let's move this over to the right here, integral of 6x to the second power, 6x squared, sine x to the third dx. Okay. All right, so what we're going to do first is we're going to split it up. We'll write the composite function first and then put the other function on the side and see what u is, and then see what we can substitute to get du or its multiple. Okay, so this can be written as the integral of composite function first, sine x to the third. Okay, can put a parenthesis around here, and then the other function is 6x squared dx. So if we call x to the third u, okay, if that is u, then what is this portion right here going to be? What is that? We don't know. Well, let's figure it out. So u is x to the third. So when we differentiate du using the power rule, is going to be 3x squared dx. Okay, so we have 6x squared dx, but du is 3x squared dx. So do you see the relationship here? Du is half of this component right here. So in order to carry out a substitution, because we don't have a perfect match, we have to multiply both sides of this equation by 2. So multiply by 2, and that gives us 2 du. 2 du is exactly what we want. 2 du is 6x squared dx. So we know what this portion is. If the inner function of the composite is u, then this part right here is going to be 2 du. Alrighty. Now let's go ahead and carry out our substitution. Our integral is now going to become the integral of sine u in this piece right here times 2 du. Okay, let's simplify by factoring out the this coefficient right here. So we have 2 times the integral of sine u du, which is a much more elegant integral to evaluate compared to the original problem. That's the beauty of the u substitution rule, is that it makes it very easy to evaluate the integral when you carry out the u substitution. All right. So now all we just have to bother with now is how to evaluate the integral of sine u. Okay, so the integral of sine u that's going to be negative cosine u, right? So we already have a 2 right there, so it's going to be negative 2 cosine u plus c. Okay, now is this our final answer? The answer is nope. That is not our final answer. What we just did is the substitution step, and we integrated. Now what are we going to do next? Do not forget to resub. Okay, resub what you substituted out back to complete the problem. So our final answer will be negative 2 cosine, instead of u, is going to be x to the third. That's what we substituted out before right here. X to the third plus c. And that, ladies and gentlemen, is the answer to question number 2. All right, let's take a look at question 3. So for question 3, what if we are to evaluate the integral of sine 3x? So what's the integral of sine 3x dx? All right, so we have a composite function, sine 3x, and then we just have dx. Okay? All right, so let's identify what the inner function is. If the inner function of the composite is u, then what is dx going to be? Well, let's figure that out. If u is 3x, you differentiate both sides, du is going to be 3 dx. Okay? So if du is 3 dx, what is dx going to be? So to know what dx is, what we're going to do is simply divide both sides by 3 because it looks like du is triple dx. If du is triple dx, then du over 3 is what we want. Du over 3 is dx. Okay, so we know exactly what dx is. Dx is du over 3. Now let's carry out the substitution step. So now we're going to sub and integrate. So when we substitute this integral, it's going to be the integral of sine. Instead of 3x, it will be sine u. And dx will be du over 3. Okay? Let's rewrite this integral so it's easy to evaluate. Factor out divided by 3, which is times 1/3, times the integral of sine u du. Okay? Now using our knowledge of integration of trigonometric functions, the antiderivative of sine is negative cosine. Okay, so if we integrate that, we're going to have negative 1/3 cosine u plus c, since it's an indefinite integral. To finish up the problem, we're just going to resub what we substituted out, which is 3x for u. So our final answer will be negative 1/3 cosine, instead of u, we resub 3x back into it, plus c. And this, ladies and gentlemen, is the final answer for question 3. Okay, let's take a look at another problem, question number 4. Now for question 4, what if we are to evaluate the indefinite integral cosine 8x dx? Alright, so this is very similar to question number 3. So I want to integrate cosine 8x dx. So the inner function of the composite function is going to be u. So u is going to be 8x. So what is this dx going to be if u is 8x? Well, let's go ahead and figure that out. If u is 8x, then if we differentiate du, the derivative of 8x is 8 dx, right? So du is 8 times dx. So if du is 8 times dx, what is dx? We're going to have to divide both sides by 8. If du is 8 times dx, then 1/8 of du is what we want. Du over 8 as dx. Okay, so we're going to replace dx with du over 8. And we are ready to carry out the substitution step. Alrighty, so let's go ahead and substitute. If we substitute, the integral is going to be the integral of cosine. Instead of 8x, we have u, and instead of dx, we have du over 8. Okay, let's rewrite this so it looks pretty. We factor out divided by 8 and write it as times 1/8 of the integral of cosine u du. Okay, now we're going to proceed to use our knowledge of the integration of trigonometric functions technique. We know what the antiderivative of cosine is, right? The antiderivative of cosine is positive sine. So 1/8 sine u plus c is the antiderivative, the indefinite integral of this function we have here. Okay, so to finish up, don't forget to resub. We're going to carry out our resubstitution steps. Substitute what we substituted out. So our final answer will be 1/8 sine. Instead of u, we're going to replace it with 8x plus c. And ladies and gentlemen, this is the final answer for question number 4. Okay, now let's take a look at question 5. So for question 5, what if we are to evaluate the integral of 2 over theta to the third sine 1 over theta squared d theta. Okay? Alright, so to do this, we're going to go ahead and separate the two functions. We want to write the composite first and the other second. Alright, so we have the integral of sine of 1 over theta squared times 2 over theta cubed d theta. Alrighty? Okay, so the inner function of the composite, let's call that u. Okay, so if this is u, what is 2 over theta cubed d theta? What is that? To determine what that is, we're going to write my 3 properly. To determine what that is, we're going to go ahead and extract our u value. So u is 1 over theta squared. So what is du going to be? So du is going to be the derivative of this guy right here, the theta, right? So in order to differentiate this, we can write this, we have to rewrite it basically, okay? So write as theta to the negative 2 prime. Write it as a power, so we can use a power rule. So du is going to be negative 2 theta raised to the negative 3 d theta. That's by applying the power rule for differentiation. Okay, so let's make that look a little bit nicer. The u is negative 2 over theta cubed d theta. Now, what is 2 over theta cubed d theta? We know that du is the opposite of 2 over theta cubed d theta. So 2 over theta cubed d theta will just basically be the opposite of du. So what we're going to do is simply multiply both sides by negative 1. And then we will be able to carry out our substitution. So negative du is equal to 2 over theta cubed d theta. That's exactly what we're looking for. Alright, so we now know what this portion is. This portion right here is negative du. We're now in the position to carry out our substitution. So when we substitute, this integral is going to become the integral of sine. Instead of 1 over theta squared, that will be u. And then 2 over theta cubed d theta will be negative du. Okay? Let's make that look pretty. We can factor out the minus. So we have minus sine u du. Doesn't this look much nicer than this monstrosity of a problem we have up here? This looks much nicer, right? That just really helps us to see the power of the u substitution procedure. Alright, so let's integrate this using our knowledge of the integral of trigonometric functions. The antiderivative of sine is negative cosine. So we have the integral of sine is negative cosine u plus c. Okay, since it's an indefinite integral, so the antiderivative is going to be cosine u plus c. Now, we're not done yet. We substituted and integrated. Now we're going to have to do the resub step to finish up the problem. Alright, so our resub step is going to give us a final answer, which is cosine of whatever u is. U is 1 over theta squared. So cosine of 1 over theta squared plus c is the final answer. Okay, one more problem before we take a look at the practice problems that you're going to try out to show to yourself that you've mastered the process of using u substitution to evaluate indefinite integrals of trigonometric functions. Number 6, what if we want to evaluate the integral of 3x to the 5th cosine x to the 6th dx? Alright, let's go ahead and do that. Now, what we're going to do first is write it in a way where it's easy to identify what u and the other component is. So You write down the composite function first, cosine x to the sixth, and then we're going to put 3x to the fifth dx on the side. Okay? Now, u is the inner function of the composite, so u is x to the sixth. So what on earth is this portion right here if u is x to the sixth? Well, let's figure that out. U is x to the sixth, so let's differentiate. Okay? When we differentiate, the u is going to be 6x to the fifth dx. Okay? So what do you notice about the relationship between the u and this component here, 3x to the fifth dx? The u is 3x to the fifth dx, so it's basically double what this is, right? So if the u is double this component right here, then what is that going to be in terms of u? To achieve that, we're simply going to have to divide both sides by 2. So divide by 2 and divide by 2. Okay? And then that's going to give us the desired value we want to substitute. Du over 2 is 3x to the fifth dx. Perfect. That's exactly what we want. That's a perfect match. So this part right here is du divided by 2. Okay? So du over 2. Now we're going to proceed to the substitution and integration step. Alright, so let's substitute. When we substitute, this integral becomes the integral of cosine u, and this whole piece right here becomes du over 2. Okay? Now we can rewrite this. Just simply make it look pretty, factor out 1/2. So we just have the integral of cosine u du. And then using our knowledge of the integral of trigonometric functions, we know the antiderivative of cosine is sine. Okay, so when we integrate that, we're going to have 1 over 2 sine u plus c, since it is an indefinite integral. To finish up, we're going to resub, and our final answer will be 1/2 sine of u. What is u? U is x to the sixth. Sine of x to the sixth plus c. And ladies and gentlemen, that is your final answer for problem number 6. Alright, so we would like you to try out these problems. So I want to evaluate the following. So try these problems out. Instructions are the same as before. You're just to evaluate the given integrals. For number 1 of the practice problem, what if you were to find the antiderivative of pi cosine pi x dx? That's question 1. Number 2, what if you were to evaluate the integral of cosine 3x dx? Number 3, what if you were to evaluate the integral of -2 over theta cubed cosecant 1 over theta square cotangent 1 over theta square d theta? Alright, what if you were to evaluate that? And then number 4, what if you were to evaluate the integral of 3x to the 5th power sine x to the 6th? Number 5, what if you were to evaluate the indefinite integral cosecant square 7x dx? And last but not the least, what if you were to evaluate the integral of x squared secant square 2x to the 3rd dx? Okay, go ahead and pause this video presentation at this time. Try these 6 problems. When you are done, click back on the play button in order to see what the correct answers are. Alright, hopefully you had a chance to try the problems. The answers are as follows. Number 1, the answer is sine of pi x plus c. Number 2, the answer is 1/3 sine 3x plus c. Number 3, the answer is negative cosecant 1 over theta square 1 over theta square plus c. Number 4, the answer is negative 1/2 cosine of x to the 6th plus c. Number 5, the answer is negative 1 over 7 cotangent of 7x plus c. And last but not the least, number 6, the answer is 1 over 6 tan 2x to the 3rd plus c. Okay, so how well did you do in these practice problems? Go ahead and let us know in the comment section below. If there are any questions or clarifications you'd like us to make concerning these problems, just let us know in the comment section below and we'll be more than glad to respond. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of use substitution, do give us a like. We'll appreciate your positive feedback. It's very valuable to us. Do not forget to subscribe to our channel for updates to other review presentations such as this. We upload videos to our page on a regular basis. If you have any questions or comments as indicated earlier, feel free to post it in the comment section below. We'll be more than glad to respond. Tons of support resources can be found in the link in the description below, or you can just visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.